Good morning, students. So we have finished our first chapter. So we move on to the next chapter, that is the chapter number 2 is matter around us pure. So that is the name of the chapter. Is matter around us pure? We know in our daily life we come across many substances, and we often use the term in our daily life. We often use the term pure and impure substances. Pure substance and impure substances. We know. Sometimes you might have heard in your home, that is your mother or your parents, they were telling that is that milk is pure, is that ghee is pure, isn't it? Or if that is that substance is that is adulteration is done or not. So these type of words you might have heard in your home or in everywhere, somewhere in the in your surroundings you may hear this word. So here pure and impure substances, but in chemistry what is pure and impure? That is in chemistry, that is in the language of chemistry, a substance is said to be pure if a substance is made up of only one kind of particle, it is called pure substance. If a substance is made up of only one kind of particle, it is called pure substance. But here, we know if we look around us, or if we are looking in this perspective, many things or majority of the things that we look around us or that is seeing around us, it is not pure. It is not in the pure form. It is impure form. And we have studied in the previous chapter that matter is made up of tiny particles. Matter is made up of extremely tiny particles, and the purity of the substance is decided by the combination of these particles, how they are combined, whether they are different forms or they are different kinds of particles. So that purity of the substance is decided by the combination of these particles. In chemistry, a pure substance can be defined as a substance which is made up of only one kind of particle, that is called a pure substance. And if a substance is made up of by the combination of two different types of substances, two or more different types of substances, that is called impure substances. If a substance is made up of only one kind of particle, it is called a pure substance, and if a substance is made up of or it is formed by the combination of two or more different kinds of particles, that is called impure substances. And here we are going to discuss about pure substance and impure substances. First we are going to deal with the impure substances. Example for pure substances we will discuss in detail later. So pure substance example elements and compounds. Elements, compounds are examples for, these are examples for pure substances. And impure substances, impure substances we can classify, example for impure substances are mixtures. So what are the different types of mixtures that we will discuss? Okay, impure substances example mixtures. In impure substances, these substances are made up of by the combination of two or more different kinds of particles. Okay. Now we will discuss in detail what is impure substance. And before that, we know this matter, a matter is also made up of matter we can classify them into pure and impure substances, and this pure and impure substance can also be further classified into different categories that we can represent like this. That is matter, matter can be classified into pure substance and impure substance. Impure substances we can, it is also called mixtures. Then this pure substance we can classify them into elements and compounds. So, pure substance can be further classified into elements and compounds. These elements can further classified into three, that is metals, non-metals and metalloids. Metals, non-metals and metalloids. And compounds can be further classified into two, that is organic compounds and inorganic compounds. Organic and inorganic compounds. And this impure substances can be classified into two. Impure substance can be classified into two, that is homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. These homogeneous mixtures, it is also called a true solution. And heterogeneous mixtures are further classified into two, that is colloids and suspension. So these are the different classifications, that is matter can be classified into pure substance and impure substance. Pure substance can be further classified into elements and compounds. These elements again classified into metals, non-metals and metalloids. Then compounds can be classified into organic compounds and inorganic compounds. Then impure substances or mixtures can be classified into homogeneous and heterogeneous mixtures. Homogeneous mixtures otherwise known as true solution, and heterogeneous mixtures are further classified into colloids and suspension. So this is the general diagrammatic representation of the different classifications of classification of matter. Okay. Now we are going to discuss about impure substance. Okay, pure substances, elements, or those things we will discuss in detail in the upcoming chapters or in the preceding chapters. So here we are going to discuss about impure substances or mixtures. impure substances or mixtures. So, impure substances or mixtures are a form of matter. It is a form of matter which are made up of by the combination of two or more, which are made up of by the combination of, or this impure substances or mixtures are made up of by the combination of two or more pure substances, which are physically mixed in any proportion, Impure substances are made up of by the combination. It is a form of matter which are made up of, which are produced or which are formed by the combination of two or more pure substances. Pure substances means elements or compounds which are physically mixed in any proportion, that is called mixtures. So, mixtures are formed by the combination of two or more pure substances which are physically mixed in any proportion, that is called mixtures. Okay, that is called mixtures. I will tell you some examples for the mixtures. Air is a mixture. Then alloys means, is a mixture of different metals, that is alloys. Air is a mixture. We know this air contain many gases. Oxygen is there, nitrogen is there, helium is there, many kinds of gases are there. So, air is a mixture of gases, and we can't say that this much percentage is there. That is, if we take some amount of gas from some space, that space may contain a particular amount of particular percentage of nitrogen, particular percentage of oxygen. So, we can't say it is what is the fixed percentage. We can't assess the fixed percentage of that air, isn't it? So, it is a mixture of gases. So, that can be mixed in any proportion. The proportion may vary, isn't it? From place to place it may vary. So, that is why it is not a fixed proportion. It may be mixed. That is, it is fixed. Physically, they are mixed in any proportion. That is called impure substance. Air, alloys, then sand and water, chalk and water. All these are mixtures, isn't it? And then sugar solution, salt solution. All these are mixtures. Air. So, these are examples for impure substance or mixtures. Now, we can further classify mixtures into two, as we discussed before. That is, impure substance can be further classified into two. That is, first one is homogeneous mixtures. Homogeneous mixtures, otherwise known as, it is a true solution. So, homogeneous mixture means what? A mixture is said to be homogeneous if all the components of the mixtures are uniformly distributed and there is no boundary of separation between each other, between the components of the mixture. That is called a homogeneous mixture. I will explain this. So, homogeneous mixture means a mixture is said to be homogeneous if all the components of the mixtures are uniformly distributed and there is no boundary of separation between the components of the mixture. That is called a homogeneous mixture. For example, if you take some water and you add some sugar or salt and you stir it, you are making a salt solution or sugar solution. If you are taking salt, it is salt. For example, if it is salt solution. So, this salt solution, when you when you take some amount of salt solution from different parts of that beaker, whether all are having the same taste, or in some area, if you are mixing it properly, if you are stirring it properly, then all the portions, all the areas, if we take the samples from this mixture, from this salt solution, all are having the same taste, isn't it? It means what? All sugar, all salt, all the salt particles are uniformly distributed in that solution. So it is uniformly distributed. All the taste is same in taste is same everywhere, isn't it? So that is called a homogeneous mixture. And can you see? Can you separate that salt and water? Can you separate? No, we can't see, and we can't see any boundaries of separation. Can you see any boundary, that is whether salt is they are lying down and water is they are up? No, it is, we can't separate that. There is no boundary of separation, isn't it? That is called that type of substance mixtures are called homogeneous mixture, because they are uniformly distributed, and we can't see that whether salt is the we can separate, we can't separate salt and water. So there is no boundary of separation. That type of substance is called homogeneous mixtures. So a mixture is said to be homogeneous if all the components, all the particles inside the mixtures are uniformly distributed and there is no boundary of separation. That is called a homogeneous mixture. Example: salt solution, sugar solution, copper sulfate solution, all these are examples for homogeneous mixtures. Okay. Then another one is, the second one is heterogeneous mixture. So what is heterogeneous mixture? A mixture is said to be heterogeneous if all the components of the mixtures are non-uniformly distributed and there is a visible boundary of separation between the components. There is a visible boundary of separation between the components. They are not uniformly distributed, they are non-uniformly distributed, and there is a clear visible boundary of separation between the components. That is called a heterogeneous mixture. Example: oil and water. If we mix oil and water, you can see that oil is, oil will lie above the water, isn't it? That will be above the water, and water, that is below the oil. And kerosene and water. If you mix kerosene and water, kerosene will be on the surface and water down. So there is a boundary of separation. We can't see that there is a boundary of separation. They are not uniformly distributed, they are non-uniformly distributed. And take another example: sand and water. You take sand and water. Once we mix sand and water, and if we keep it for some time, we can see that all the sand particles will settle down. It will settle down, isn't it? So there will be there is a visible boundary of separation. Water will be up and all the sand particles will be, they will be settling down in the bottom, isn't it? So this is called a boundary of separation, and that can be seen. It is visible and they are non-uniformly distributed, because if we it is not just like a sugar solution, or it is not just like a salt solution. They are non-uniformly distributed, because when we if we keep undisturbed, for example sand and water, if we keep undisturbed, all the sand particles will settle down, and at that time you can see that water is pure. Water will be they are lying above the sand, and it is pure. They are not uniformly distributed. This is called heterogeneous mixtures. I hope you understood what is homogeneous and heterogeneous mixtures. And we can take we can do one example. For example, if we can take 4 test tubes, A, B, C, D. In one test tube, in all these test tube, you are taking 50 ml of water. Take equal amount of water in all the test tubes, and in test tube A, you are adding 1 gram of copper sulfate. Copper sulfate, CuSO4 means copper sulfate. You are adding 1 gram of copper sulfate in test tube A and 2 gram of copper sulfate in test tube B, and in test tube C, you are adding a mixture of copper sulfate, then plus chalk powder. A mixture of copper sulfate and chalk powder, and here also you add a mixture of salt solution. So you are adding salt, not salt solution, you are adding salt plus potassium permanganate, that is KMnO4. You might have heard about this. You might have seen KMnO4 from the lab. KMnO4 and then a mixture of salt plus KMnO4. Now, after mixing, you just you are stirring it properly and keep it for some time. And here you can see that in test tube A and test tube B, we can see that here we are adding copper sulfate solution and we get a copper sulfate solution, and so that will be blue colored solution, and here also we get a blue colored solution of copper sulfate. But what is the difference between the test tube A and B? Here we have taken only 1 gram, here we have taken 2 gram. So there will be a slightly color change. Here the intensity of color is more in test tube B than in test tube A. Why? Because here we have taken 1 gram and here 2 gram. So here 2 gram is distributed uniformly in 50 ml of water, but here 1 gram is distributed uniformly in 50 ml of water. 1 gram is distributed in 50 ml of water. So test tube A and test tube B, they are called what? Homogeneous mixtures. They are called homogeneous mixtures. But the thing is that both are homogeneous, but the composition is different. So so in a homogeneous mixture, we have a variable composition. In a homogeneous mixture, we have variable compositions. That depends on the amount of substance that we are taking. Okay. That is, so here both A and test tube A and B, they are homogeneous mixture, and test tube C and test tube D, here we have taken a mixture of copper sulfate and chalk powder. Copper sulfate and chalk powder, they are not miscible, they will not mix, each other. So that is why it is non-uniformly distributed, and there is a visible boundary of separation because chalk powder will be settling down. Copper sulfate may be dissolved in water, but chalk powder is settling down in the bottom. And here also, if we take salt solution and KMnO4, you can't see that we can't. There is a, but in salt we cannot see the salt, but it is also what? The salt is also dissolved in water, and KMnO4 is also there. So it is also a what? It is instead of salt, because we can't see the salt. Instead of salt, you can take copper sulfate and KMnO4. a mixture of copper sulfate and KMnO4. Here also a mixture of colors will be there. So this is also an example for these C and D. They represent heterogeneous mixture. Heterogeneous mixtures. Okay, I hope you understood what is homogeneous and heterogeneous mixtures. Okay, then next we are going to discuss about solutions. I told you that solutions is a homogeneous. So what is a solution? A solution is a homogeneous mixture of two or more substances. A solution is a homogeneous mixture of two or more substances, two or more chemically non-reacting substances. That also, in that way also we can define what is a solution. Simply we can say that solution is a homogeneous mixture of two or more substances. And in a solution, solutions are of different types of solutions are there. That is solid solutions are there, solid solution, liquid solution and gaseous solutions. Solid solution, liquid solution, gaseous solutions. Solid solution example, solid solution alloys. Alloys are examples for solid solution, because you know brass, you heard about brass. What is brass? You know, brass is an example for a solid solution. Brass is a mixture of zinc and copper. Zinc and copper. Zinc is 30% and copper is 70%. That is called a brass. So both are solids, they mixed uniformly, but here we have taken only 30% zinc and 70% is the remaining percentage is what copper, but they are mixed uniformly, and that is why that is called brass, and it is an example for solid solution. Liquid solution example, many examples are there. For example, alcohol and water. Alcohol plus water. Vinegar and water, all these are examples for liquid solution, because liquid solution. Then gaseous solutions. Gaseous solution, air is a gaseous solution. Air contains many gases, nitrogen, oxygen, hydrogen, etc. Many gases are there. So air is an example for gaseous solution. So solution is nothing but it is a mix. It is a homogeneous mixture of two or more substances. That is called a solution. Then in a solution, when we are studying about solution, solution contain mainly two components. Mainly two components are there, that is solvent and solute. A solution contains two components, that is solvent and solute. So what is a solvent? What is a solvent? Solve means in a solution the substance, solvent is, it is a component of a solution which dissolves other substances. Solvent is, it is a component of a solution that dissolves other substances in it and which are present larger quantity, that is called a solvent. It is a component of the solution that dissolves the other substances in it. The other substances in it which are present larger quantity is called solvent. I will tell you one example. For example, if we make copper sulfate solution in water, if we dissolve copper sulfate in water, copper sulfate will take smaller quantity and water will take a larger quantity. So here water is what? Solvent. Water is solvent. Why? Because that is present excess quantity. That is present excess quantity, and in water copper sulfate is dissolving. So the component of the solution in which that substance dissolves the other substance. Here copper sulfate, the other substance is copper sulfate. Copper sulfate is dissolved in water. So copper sulfate is what? Here water is what? Water is the solvent in this copper sulfate solution. And what is solute? It is the component of a solution. It is the component of a solution that is dissolved in the solvent of the solution. The component of the solution that is dissolved in solvent, and which is present lesser quantity, that is called a solute. Here copper sulfate is the solute. Why? Because copper sulfate is dissolved in the solvent water, and so this is a solute and this is solvent, and this solute will be lesser quantity as compared to solvent. Solute is lesser quantity, solvent is larger quantity. Okay, that is solute and solvent. I hope you understood what is solution. Okay.